In this video, we are going to build this LED distance indicator using an ultrasonic sensor, an Arduino, and multiple LEDs. As you can see, when I move the object closer to the ultrasonic sensor, more LEDs come on. And when I move it away, the LEDs turn off one by one. This project has real-life applications in car parking assistance systems, robot obstacle detection and navigation, and water tank level monitoring systems. To make the project, we need the following components: an Arduino board, an ultrasonic sensor, 10 light-emitting diodes, 10 220 ohms resistors, some jumper wires, and a breadboard. In this project, we will be introducing a new component that we have not worked with before, and that is the ultrasonic sensor. The ultrasonic sensor helps us measure distance using ultrasound, and here is how it works. This is the ultrasonic sensor. This is the HC-SR04 Ultrasonic Sensor. It has 4 pins: the VCC pin, the Trig pin, the echo pin, and the ground pin. It also has 2 bands: the transmit band and the receive band. This sensor sends out ultrasound and receives the ultrasound to be able to calculate distance. How does that work? Well, like I said, the sensor sends out ultrasound. Ultrasound is a sound wave that has frequency that is beyond the audio frequency. Audio frequency is between 20 to 20 kHz. Anything beyond 20 kHz is called ultrasound. This ultrasonic sensor works with a frequency of about 40,000 Hz, that is 40 kHz, and that makes it ultrasound. That is why it is called ultrasonic sensor. Now here is how the sensor works to measure distance. The sensor sends out ultrasound from its transmit band. When that ultrasound meets a barrier, the ultrasound is reflected as echo and the receive band receives it. With the help of the circuitry in this sensor and with the help of the code which we will upload to our microcontroller, that is the Arduino board, we will be able to compute the time it took that ultrasound to get transmitted and get received. With this time and the speed of sound, which is about 340 meters per second, we can calculate the distance between the band of this ultrasonic sensor and the barrier, and that gives us the distance of the barrier from the ultrasonic sensor. Now let's look at the circuit diagram of the project. This is the circuit diagram of our project. This circuit diagram is similar to the diagram we used for our previous project. The only difference is that we added the ultrasonic sensor. Here you can see our Arduino board, the ultrasonic sensor, the 10 current limiting resistors, and the 10 light emitting diodes. You can change these light emitting diodes to any color of your choice. Here we have the same connection we had in the previous project. We used pin 2 to 11 as the Arduino pins. We connected the LEDs through the current limiting resistors. And for the sensor, we connected the VCC pin to 5 volts of the Arduino board. We connected the ground pin of the sensor to the ground pin of the Arduino board through this jumper wire. And then we connected the Trig pin of the sensor to pin 12 of the Arduino board. And we connected the echo pin of the sensor to pin 13 of the Arduino board. Now let's connect the physical circuit using this circuit diagram as a guide. This is the circuit of our project. Here we have the Arduino board, the ultrasonic sensor, the 10 light emitting diodes, the 10 current limiting resistors, a breadboard, and some jumper wires that helped us to make the connection. The LEDs are connected to pin 2 to pin 11 of the Arduino board through the 10 current limiting resistors, while the Trig pin and the echo pin of the sensor is connected to pin 12 and pin 13 of the Arduino board. The VCC pin of the sensor is connected to 5 volts pin of the Arduino board, while the ground pin of the sensor is connected to the ground pin of the Arduino board. So with that done, our circuit is now complete. Remember that this circuit is exactly what we have in our circuit diagram. The next thing is to connect the Arduino board to the computer, upload the code to the Arduino board, and we'll observe what happens. So let me do that. This is the code for our project. Here, this line of code is what we use to declare the pins where the sensor will be connected. You can see that we have the Trig pin connected to pin 12 and echo pin to be connected to pin 13. The line of code here is to create an array of pins where the LEDs will be connected. So we have that the LEDs will be connected to pins 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. This line of code is where we declare variables to store duration and distance. If we come to the setup function loop, it's where we set the variables to either input or output. You can see here that we set the Trig pin to be output and then the echo pin input. If you come to the void loop, we have a code to measure distance 5 times and calculate the average. So this code here is to measure distance 5 times and calculate the average of 5 measurements. Then we have another code here to determine the number of LEDs to turn on and to turn off. So this part of the code determines the number of LEDs that will come on and the number of LEDs that will turn off. Remember that what we are trying to build is a distance indicator using LEDs. So as we bring the obstacle close to the U sensor, that is the ultrasonic sensor, the LEDs light up more. But when we move the obstacle or objects away from the sensor, the LEDs go off one by one, the same way they came on. So it is this code that determines the number of LEDs that will come on and those that will go off depending on the distance measured, while this code turns on or turns off the LEDs. So this code is to turn off or turn on the LEDs. Now let's upload the code to the Arduino board and we will test our project. So I will click upload and we'll observe what happens. By the way, I've already connected the Arduino board to the computer and set it up to interact with the Arduino IDE. So the code has compiled and uploaded to the Arduino board. Let's now test our circuit. I will bring a barrier. This is my barrier. I'll bring this barrier and place it in front of the ultrasonic sensor. As I bring it close to the ultrasonic sensor, I expect the LEDs to start coming on one by one. So you can see the LEDs are coming on. One is not on. What's the problem? I will check the resistor, check the wire. Okay, it's on now. So as I draw closer, as I bring the object closer to the sensor, the LEDs come on one by one. And as I take the object away from the sensor, the LEDs go off one by one. You can see. So let me do it again. On, off, on, off. You can see that we are indicating distance using LEDs. The number of LEDs that turn on tells us how close the object is to the sensor. As the object is getting close to the sensor, the LEDs light on the more. And once it is very close to the sensor, all the LEDs will come on. If I take the object back taking it away from the sensor, the LEDs start going off one by one. So our project is working exactly as we want it to work. And what makes it work is the sensor, the Arduino board, and the code we have in the Arduino board. And do not forget that you can find the code for this project with the link in the description of this video. In this video, we built an LED distance indicator using an ultrasonic sensor. This sensor allows us to measure distance using sound waves and display it with LEDs in real time. This is just the beginning of the many exciting Arduino projects we'll be building in this series. I am Instructor Izu, and I look forward to seeing you in the next video. Bye.